Good morning. Myself, Dr. C.J. Kadam, Head, Department of Physics, Maharashtra Mahadhyaya. Today, we will enlighten sinusoidal oscillators. Many of the electronic devices requires source of energy with a specific frequency which may be ranging from few hertz to several megahertz, and this is achieved by an electronic device called as an oscillator. So oscillators are widely used in many of the electronic devices, like in radio receivers, TV receivers, transmitters, TV transmitters, also in radars, and in many of the electronic devices. Now, oscillators can produce sinusoidal oscillations and non-sinusoidal oscillations. We shall say that what is meant by sinusoidal oscillation and non-sinusoidal oscillation. That is, sinusoidal oscillations in the sense those oscillators which are giving the sine waves as its output, whereas non-sinusoidal oscillators are those oscillators which are giving the non-sinusoidal, in the sense that is the either square waves or any other waves except the sine waves. So we call that non-sinusoidal oscillations. So sinusoidal oscillators are those devices. It is a device, electronic device, which produces sine wave as its output. Oscillator itself, we are stating that it is an electronic device which, by getting DC energy, converts it into the AC energy. Now, of desired frequency, that energy, that the waveform which is to be produced is of desired frequency. That is ranging from few hertz to several megahertz. Now, this oscillator, while speaking about the oscillator, we also mentioned that is an alternator can produce the waveforms up to 50 hertz. So we cannot say that alternator as an oscillator, because alternator converts the energy, the mechanical energy, into the AC energy, whereas this oscillator it gets the DC energy and converts it into the AC energy. Alternator has, that is, rotating parts in it, whereas oscillator is not having any rotating parts in it. So we will see the advantages of this oscillator. Oscillator gets the DC supply, from the DC supply gets the DC energy and converts it into the AC energy. It is just merely a converter. So we will see the advantages of this oscillator. So as it is having no rotating parts, therefore the wear and tear is not there, therefore it lasts for a long life. As it is not having any rotating part, it's not a rotating device, therefore the frequency which we get as a stable one, stability is good. Once we set the frequency, it will remain constant. The frequency which we get from this one may range from we can change the frequency, it may range from few hertz to several megahertz, and efficiency. So these are the advantages of the oscillator. Okay. Now we shall see the types of oscillations. The oscillations are of two types. Sinusoidal oscillations are of two types. One we say that was a damped oscillations, and the another one we say that is the undamped oscillations. Damped oscillations are those oscillations which are, after a certain time, the amplitude of these oscillations goes on decreasing and finally it merges, so that we call these oscillations as damped oscillations. On the other hand, those oscillations, the oscillator which is giving the waveform, from which the waveform which is to be obtained is, we are getting the constant amplitude waveform. We call such type of oscillations as undamped oscillations. So we shall see one by one what is meant by oscillator. So sinusoidal oscillator we are going to study here. So we have to find that it is an electronic device which converts the DC energy into the AC energy with the desired frequency. Okay, so it has no any rotating parts, therefore the it lasts for the longer life. Its frequency is a stable one, and its efficiency is high. Okay, it gives the oscillations of the type we have stated that the sine waves. So therefore we are showing that the sinusoidal oscillators. And then we are going to say something about the types of the oscillator. Types of these oscillations. Okay, damped oscillations and undamped oscillations. If you plot a graph of the waveform which we are getting from this type of device, say the amplitude versus time. Okay. So the amplitude gradually goes on decreasing and finally it merged out. So this type of oscillations are called as damped oscillations. On the other, here for every oscillation, for every cycle, there is a loss of energy, and the loss of energy is further not replaced, or that is, the losses are not gained. Therefore, we find that finally the waveform gets merged. On the other hand, the second type we are going to say something about the undamped oscillations. So we will find oscillations to be with constant amplitude. So here also we are plotting the waveform in between the amplitude versus the time. Okay. So in this case, whatever the oscillations we have obtained is having constant amplitude, so that we are calling this type of the oscillations as undamped oscillations. So we are interested in such type of, here, even though there is a loss of energy that has been just overcome by providing the supply. Okay, so this is undamped oscillations. Now, as we have seen that the sinusoidal oscillator, why we need the oscillation to convert the energy from one form to the another form, that is DC energy has been converted. So we have compared this one with the alternator. Alternator is just giving us the uh, waveforms up to 50 hertz only. If we need the waveforms greater than 50 hertz, so the alternator is not giving this type of waveform. Therefore, we are making use of the sinusoidal oscillators. Okay, so we can produce the waveforms having the frequency from the very few hertz to the several